Forward, firstly we'll see the definition, some key features and modularity. So what is object oriented development and what is it, we'll go through. So object oriented development is a method of software design and programming that involve organizing software as a collection of interacting objects. Next is key features. So object-oriented development is characterized by several key features including modularity, reusability, extensibility, and maintainability. If you want to go more further about what these features are, you can just go through the deep into this topic to know what basically it really has. The next is modularity. So object-oriented development promotes breaking down a program into smaller management and usable pieces, making the code easier to understand and maintain. So in modularity, there's a big code which is just separated into smaller codes that can be solved easily, and then after solving the small codes, it can be put together to make a large code, so it is easier to solve any large code problems. So moving forward, there are some of the object-oriented themes, that is abstraction, encapsulation, hierarchy, typing. So we'll see what are these and how we can just go through the definitions. So abstraction focuses on essential qualities rather than specific characteristics, allowing developers to create general representations of object and their behavior. So this is all about the abstraction. If you really want to know what really this is, then we can go more to the deep. But now I'm just covering the what basic it is. Next is encapsulation. Encapsulation combines data and behavior in single entity, hiding internal state and requiring all interaction to be performed through an object's methods. Next is hierarchy. Hierarchy organizes abstractions into classification theme, allowing for inheritance and polymorphism, promoting code reusability and extensibility. The next is typing. Typing enforces constraints on objects to ensure correct behavior, preventing any errors and improving code reliability. So we have seen what object-oriented definition is, and these are some of the themes which covers abstraction, encapsulation, hierarchy, typing. This is just the main definitions. We haven't gone through any of the depth. Moving forward, we have evidences for usefulness of object-oriented development. We in this slide we'll come to know why the object-oriented development is very important and what are the uses. So first is improved software quality. Next is increased productivity, scalability and flexibility, real-world modeling. We'll just go through a description of each of them. Improve software quality, enhance code readability and maintainability, easy debugging and testing. So object orientation makes the software quality more increase. It makes it more user friendly so that the code can be easily read, easily the code can be debugged and any of the errors can be find out and easy for testing. Next is increased productivity. So reusability of code components, faster development cycles. So when what is productivity basically is that the code which has been generated for previous programs can again be regenerated, and we can just modify the little bit of it and it is ready for the uh, next project. Next is scalability and flexibility. Increase to the scale and extend application and adaptable to changing the requirements. So due to object oriented, the any of the software project or modeling is very easy to increase according to the user need, and also it is very flexible to adopt to any changes that we made during the execution of program or in the starting or in the ending. So this is all about the flexibility and scalability. There are many more uses of them, but these are the some of few which I have summed up. Next is real world modeling. Closure alignment with real world entities and relationships, more intrusive design process for developers. So real world modeling, it keeps in mind what the real world wants and how it basically helps. So it has better relationship, process of developer is easy. So this was all about the useful of object development. There are many more benefits and many more advantages of using object oriented development for software projects. So moving forward, then next is what is the history of object modeling and how it came up. So early concepts. So in early concepts, we introduced it in 1960 with Simule language, and Simule introduced the concept of classes and objects, laying the foundation of object-oriented programming. And next in early 80s, 1980s and 1990s, so widespread adoption with language like Smalltalk, C++, and Java, development of methodologies like BROSH, OMT, and UML. So OMT stands for Object Modeling Technique, and UML stands for Unified Modeling Language. So if we go, this was some early concept around 1980s, and during that phase when it was like usually started to introduce. Moving forward in the modern era, then how it just got developed and how it just got modified in the modern era. So, in the modern era, integration into most modern programming languages like Python, C++, Ruby, and this all development of advanced modeling tools and frameworks, and engineering practices including Agile and DevOps. So these are the some this like summarization of how the object oriented started in the early 90s and how it came up in the modern era. This is just an overview of how it happened. We have more deep concepts which we will learn. We'll more know how it usually start and how the idea of this came and how this is being developed with the different processes happening. Next is conclusion. So and now what we have seen in the previous slide is just a basic starting of what is object oriented and how it is useful for software projection. So, concluding this presentation is that object orientation provides a robust framework for software development, empathizing modularity, reusability, and real-world modeling. Its, his, its historical evolution demonstrates its growing importance and integration into modern development practices. Object orientation continues to shape the future of software engineering, offering a powerful and versatile approach to building complex and efficient applications. So this is all about the object orientation and how it is useful and how it will shape the useful the modern software engineering projects and all. So that's all for today's presentation. Thank you and hope you liked it.